Sir, you are mute. Sir, please unmute. Sir, you are mute.
Yes.
Yeah, please. Sir, please take care of this. Yeah. Now please
Yes.
start. Yeah.
Okay. So let me explain this question one more time. There was a problem with audio. Now I think it is clear. Now I think my audio should be clear to you. Let me explain this question one more time. Now this is the question number 1. As I said, that we are focusing on ISRO and ICRB questions from thermodynamics and its applications from the year 2016. Okay, and this was my brief introduction. So my name is Vipin Kumar Yadav, and I have done my MTech from IIT Kharagpur, and I have around 5+ years of GATE, ESC, and AJE exam teaching experience. Okay, so let us start with the first question. So what the question is saying, let us see. It says that starting from the same initial condition, an ideal gas. So first of all, this is a very important point that you need to mark, that we are talking about ideal gas. So an ideal gas expands from volume V1 to V2 in 3 different ways. Okay. So what is the process that is happening here? Expansion is happening here. Okay. Expansion is happening. Now, in the first process, the work done is W1 if the process is purely isothermal. Okay, so what can I say? That the first process is isothermal. First process is isothermal. First process is isothermal, and work is W1. Okay. Now the second process is purely isobaric. So isobaric. And what is the work that is produced by this process? W2. Then the third process that is happening is adiabatic. Third is adiabatic, and the work produces W3. Now they are asking, basically we need to compare the work. In which process we are getting the maximum work output? Because it is expansion, so it will be work output. Now, I hope you all know, we have discussed it many times. Even in my class, I have discussed it if you have done it with me, that all processes, whether it is isobaric, let me write, all thermodynamic processes can be expressed by a general equation, which is PVK is equals to constant, right? This is a very general process. Okay, this equation can be applied to any process, whether it is isochoric, then only the K value will be infinite. Slope will be infinite. Okay, whether it is isobaric, so what will be K? K is equals to 0. K is equals to 0. Everything we have explained in class. When it is isothermal, then K is equals to 1, right? When it is adiabatic, then K is equals to gamma, which is equals to 1.4. And when it is polytropic, then K is equals to N. And this value of N lies between 1 to gamma. Okay. Now, I hope you also remember how we can express these processes on the PV diagram. So if I have to show expansion, basically you see this process is what? If you can tell me what is this process, or what is the slope of this line? So this slope of this line is K is equals to 0. Really sorry. The slope of this line is 0. And what is the slope of this line? Here, k is equals to infinite. So you see, this is your isochoric line. And this is your isobaric constant pressure line. This process, you see here, what is happening here? Here, pressure is increasing and volume is decreasing. So this quadrant shows compression, because in compression, what happens? Pressure increases, volume decreases. Now, what will happen in this quadrant? You see, here pressure is reducing and the volume is increasing. So this quadrant is expressed as expansion. This quadrant is expressed as expansion process, because here pressure is decreasing, volume is increasing. Now, so because we are talking about in this we have three expansion processes: isothermal, isobaric, adiabatic. Okay. Now, as we can see, this curve, you see this curve. This curve is basically isobaric. This is isobaric. Okay. What will be isothermal? So isothermal, now here slope is k is equals to 0. Here slope is k is equals to infinity. So basically slope is increasing in this direction. So k is equals to 0 is isothermal. Sorry, k is equals to 1 is isothermal. And k is equals to 1.4 is adiabatic. That means isothermal you have to draw near this slope. Okay, here k is equals to 0, right? So k is equals to 1 will be near to k is equals to 0. And k is equals to 1.4. That means gamma adiabatic. So this is your isothermal. And this is your adiabatic. Because you see, slope is increasing in this direction. So here slope is 0, here slope is 1, here slope is 1.4, here slope is infinite. Okay. Now let me take this to new page. Okay. So now we are not talking about compression. Okay. Now we are not talking about compression. So we are all, so this is compression, right? This is compression, but we are not worried about compression. We are worried only about expansion. Now, as you know, work done in a closed system is given by area under curve, right? Area under curve when extended on what axis? When extended on what axis? Volume axis. Volume axis, right? So whatever area under curve on the volume axis will give us the work transfer, right? So let's see. So what is the area under constant pressure curve? So all this area, you see, let me draw it by green line. So this is your constant pressure, right? This is your isobaric. So what is the area? All this area is coming under isobaric curve. What about isothermal? So this all green area is your W2. Okay, isobaric. How about the area under isothermal? So this blue, so this is your isothermal curve, and all this blue area is your W1. 1. What about the third process? Third process is your adiabatic process. So what is the area under this? This area, red area, red area. So this is your red area, is your W3. So by seeing the size of green area, blue area, and red area, I can say that W2 is greater than W1 and it is greater than W3. W3. Got it? So this is your correct option. So what is the correct option? W2 is greater than W1 and it is greater than W3. So A is the correct answer. Okay. I hope it is clear. Okay. Let's move on. Now, next question. A house refrigerator with its door open is switched on in a closed room. The air in the room is, what will happen with the air? What will happen with the room air? What will happen with the room air? So it is saying that you have a refrigerator. You see, this is your refrigerator and it is always anti-clockwise. Okay. So what actually it does is it takes heat from your refrigerator and gives it to the room. Okay. And to do this, you have to provide some work output. So what is this work output? Your electric energy. Okay. Now, if you do an energy balance around this, you will get Q1 because it is coming in plus W in. Sorry, Q1 is equals to W in plus Q2, right? So from here, I can say that Q1 is greater than Q2, right? Because Q1 is summation of two quantities, right? Now this is the case. This is the case when the door is closed. Okay, this refrigerator is taking this heat Q2 from inside the refrigerator, but when the door is closed, when the refrigerator door is closed. Now, what will happen when the door is open? So if refrigerator door is open, if it is open, then there is no clear boundary for the refrigerator to take the heat, right? Then what will happen? So now Q2 is the heat absorbed from room. So Q2 amount of heat is absorbed from the room. And then Q1 is anyway going to, Q1 is heat given to the room. Okay. And Q1 is added to the room air. Q2 is taken from the room. Okay. So we are taking, let us say, and you see, we know this logic as well, that Q1 is higher than Q2. So let us say that we are absorbing 50 kilojoule of heat from the room, but we are giving 100 kilojoule because it is greater. You see, we know it is greater. So what will happen with the room air? So therefore, room air or room air will heat up. Okay. So I hope it is heated. So it will heat up. So what is the right answer? It is heated. It is heated, right? Sure. Let's move on to the next question. Now, a 10 kilowatt drilling machine is used to drill a bore in the small aluminium block. Okay, so of mass 8 kg. So what is mass? Mass is equals to 8 kg. What is the rise in temperature of the block in time? Delta T 2.5 minutes. What is the rise in temperature of the block? That means what will be delta T, assuming 50% of the power is used up in heating. So what is happening here is, you see, this is electrical power. We have connected our drilling machine with electricity. So we are giving it work input, electrical energy. And out of this work input, 50% of work input is converted to 50% is converted to heat. 50% is converted to heat. Okay. And that heat will, so if this is your block, this is your drilling machine, and we are giving work input is equals to 10 kilowatt. What is this work input? Electrical work. Now out of this, when it is drilling, then heat will generate. Okay, Q out is basically 50% of W in. So what is Q is equals to 5 kilowatt, right? 5 kilowatt. And this is basically responsible for the temperature change. So I can say it is equals to MC delta T. So basically this heat, what heat? Q is equals to MC delta T. Now this heat is basically 5 kilowatt. What is mass? 8 kg. What is C? C is 0.91 kilojoule per kg degree Celsius. Kilojoule per kg degree Celsius. Delta T I need to find out. But they are asking in 2.5 minutes. In 2.5 minutes, you see, this is basically here, it is what degree Celsius. So basically, kg and kg will get cancelled. Degree Celsius and degree Celsius will get cancelled. Now, this side we have units of kilowatt. This side we have units of kilojoule. So basically, we need to convert one of the units. So now what can I say? It is 5 kilojoule per second into 2.5 minutes into 60 seconds per minute. So minutes and minutes, seconds and second. Now only kilojoule is there. So it is 8 into 0.91 into delta T. So now the units are same. Now you can calculate delta T is equals to 103 degree Celsius. Degree Celsius. Got it? Chalo. Let's move on to the next question. Okay. A block of ice at -10. So ice is at what? -10. Is slowly heated and converted to steam at 100 degrees Celsius. Which of the following curves represent the phenomena qualitatively? So I hope you're all aware of the concept of phase change, I think. Okay. So let us say this. Now, you see, how ice is getting converted to steam. So first of all, let us say you have some temperature here. What? Minus 10 degree Celsius. Or what is this? This is ice. This is ice. Now, when you are giving some, this is ice at minus 10. Now, when you are giving this heat to it, its temperature will increase. So its temperature, so this side its temperature. Okay. So temperature will increase to, temperature is going to increase to 0 degree Celsius. Okay. Its temperature is going to increase to 0 degree Celsius. Now, what is the 0 degree? It is the melting point. It is the melting point, right, of ice. So after this, ice will start converting into water. So this is what here, it is ice. Now, when it will reach to the saturation temperature, which is melting point 0 degree Celsius, now the temperature will not increase. So what will happen now? Only phase change will happen. Only phase change will happen. Okay. So here it is what? We are working at 0 degree only, but ice is converted to water. Okay. So this is basically called as sensible heat. And when it is completely converted into water, the whole heat absorbed is called as latent heat. Of what? Of fusion. Of fusion. Now you see ice here, it is complete ice. Here it is complete water. Now we have water at 0 degree Celsius. Water at 0 degree Celsius. Now what will happen? Now this water will start absorbing heat and its temperature is going to increase to what? 100 degree Celsius. So it will increase to 100 degree Celsius. Now this is basically we have reached at 100 degree Celsius. So this is simple water. Only temperature change is happening. Temperature of water is increasing from 0 degree Celsius from here to 100 degree Celsius here. Now what is this 100 degree? It is the steam point. It is the saturation temperature. Now the phase change will happen. So whatever heat is absorbed till here, it is called as sensible heat. After this, the phase change will start, and phase change, yani ki water will start converting to steam. Water will start converting to steam. Now, what do we have? Water plus steam. So here it is complete water. At this point is complete water. At this point it is complete steam. So whatever heat is absorbed here is latent heat of vaporization. Little concepts are required here. Little concepts are required, but it's a very simple thing. Okay, this is called as water plus steam. So basically, if further you will go, then now the steam temperature is going to increase, but basically they have not given this. So we have to only take from steam for steam at, so what is here? You see, at this point we have ice at minus 10 degrees Celsius. What is here? We have steam at 100 degree Celsius. So this is our process that is happening here. So what is the most similar graph in this diagram? So you see, this is not true, we know. Also, this cannot happen. Here one graph is missing. Here this line is missing. So this is also not possible. So basically the right answer is A. A is the right answer. Got it? Chalo, let's move on. Let's move on to the next question. Now the working temperature in evaporator and condenser coils of a refrigerator are 25. Now, okay. So what is the question saying? Let's see. We have a refrigerator, you see. What do we have? We have a refrigerator. So let us draw a refrigerator. This is a anti-clockwise device that absorbs Q2 from the evaporator or the lower temperature. So this is evaporator and transfers it to higher temperature. So in this case, what do we have? Condenser is higher. And in order to do that, we require work input. So this is Q1. This is Q1. Now the evaporator is at minus 25. Evaporator is at minus 25 degrees Celsius. And condenser is at 30 degrees Celsius. The COP of the refrigerator is 0.8 of COP of maximum or Carnot. And work input is 2 kilowatt. Refrigerator effect. That means this is your refrigerating effect. This is what they are asking. This is what they are asking. So first of all, let us see what is COP of Carnot. So COP of Carnot, I hope you are all aware. It is T2 by T1 minus T2, right? Lower temperature divided by higher minus lower. What is lower temperature? 25 if you convert into Kelvin, it will be 248 Kelvin. And this will be 303 Kelvin. Okay, always put them in Kelvin. So 248, 303 minus 248. So here maximum you will get 4.51. So now I can find out my COP. So this COP is, actually let me put it here itself, 0.85 into 4.51. So this is 3.83. Okay. Now this COP actual is also refrigerating effect upon work input. So from here I can find out refrigerating effect Q2 is equals to COP into work input. So 3.83 into 2 is equals to 7.6 kilowatt. So this is your refrigerating effect. So 7.6 kilowatt, that is A option is the correct option. Got it? I hope it is very clear. Okay, let's go. Okay, so this is thermometer. This is based on Zeroth law. Okay, we have also studied this in temperature measurement, how we used to measure the temperature. So basically here, let us read this question. Now, this question is saying that a mercury thermometer was first placed in a melting ice and the length of, so first of all, what do you know about this? So we have studied that, first of all, we know one thing, that temperature is a linear function of thermometric property, right? So let us say temperature is T and thermometric property is X. So I can say T is equal to some constant ax plus b. Okay. Now it is saying a mercury thermometer was first placed in melting ice and the length of mercury column was observed to be. So basically when temperature, let us say T1 is equals to ice, that means zero ice point, 0 degrees Celsius, then thermometric property X1 will be 10 millimeter. Now when it is placed in steam, steam is what? Steam point, which is 100 degrees Celsius, then column's length is 250 millimeter. Now when it is placed in water, the length of column is, so now T3 I don't know. T3 I don't know. Yani ki water temperature I don't know. But X3 is given to be 58 millimeter. So basically they are asking to calculate T3. So I can say T3 is equals to A, or I can say this is X, okay? Or I can say, just one second. I can say 58x, sorry, 58a plus b. Now, if I know a or b, then I will be able to find out T3. How do I find out a and b? How can I find out a and b? Of course, I have one equation, and these are two constants. There are two constants, okay? And I can, these are kind of boundary conditions, okay? So I can substitute in this equation and find out by two equation, two unknowns, a and b. Okay, I will be able to find out a and b. So let us try to put this. So let us say put first equation. Okay, so temperature is 0 is equals to a, or 10a plus b. Second is what? 100 is equals to 250a plus b. So if you subtract this, this will get cancelled. Minus 100 is equals to minus 240a. So a is equals to 10 by 24. 10 by 24. Now from here, can I say a is equals to b by 10? By 10a is equals to minus b. So a is equals to minus b by 10. But basically we need to find out b, right? Yeah, so b is equals to, now I can say b is equals to minus a basically. From this equation, I can find out that b is equals to minus 10a. So let me substitute the value of a here, and b is equals to minus 100 by 24. So now I know a and b. I can find out 23 is equals to 58 into 10 by 24 minus 100 by 24. So it's very simple, just calculation. T3, or temperature of water, we will find out 20 degree Celsius. 20 degree Celsius. What is the right answer? It's B. Got it? Chalo. Let us move on to the next question. The amount of steam. So steam is at what? 100 degrees Celsius. Required. So steam temperature is fixed. Okay. Required to raise the temperature of 200 grams of water from 60 degree to 100 degrees Celsius is. So basically you have a hot steam at higher temperature and you want to warm, you want to hot up your water from that. So what can I say? I can say heat rejected from steam will be equal to heat absorbed by water, right? Whatever heat is given by the steam is absorbed by water and to increase its temperature. Okay. So what is this mass of steam into latent heat? Because it is at a fixed temperature, so you will use into latent heat. This is mass of water into Cp into dt. Okay. So I need to find out mass of steam. These value you need to know. You see, they have not given it. You need to know this for water. 2257 is equals to mass of water is given. Okay, this is mass of water, 0.2 kg into again this value you must know, 4.18 or 4.2 kilojoule per kg Kelvin into 100 minus 60. So mass of steam will be 0.0148 kg or 14.8 grams. So it's 14.8 grams. Got it? So I hope this is clear. Let's move ahead. Let's move ahead to the next question. Very simple. I don't think you can get a question easier than this. A engine works on Carnot cycle. So it is a Carnot engine. And what temperatures between 727 to this temperature, the efficiency of the engine is. So very simple question. You have a heat engine that is Carnot and it is working between 727 degrees Celsius and 227. 227 degrees Celsius. It is absorbing heat from here, giving heat here and producing some work output. We have to find out the efficiency. So we all know efficiency of Carnot will be equals to desired output, which is work output, by heat input, which is Q1. And we can also say it is Q1 minus Q2 by Q1. Or we can also say T1 minus T2 upon T1. So this is basically, so what is this? 1000 Kelvin. What is this? 500 Kelvin. So this is basically 1000 minus 500. It is minus, okay? Don't get confused with this. This is minus and 1000. So very simple calculation, 500 by 1000. That means 0.5 or 50%. The answer is 50%, which is A. Okay. I hope it is absolutely clear. Okay. So should we move ahead? Now, the next question is a steam thermal power plant works on. A steam thermal power plant works on. So I hope you all can answer this, right? It's a very simple, very simple question. So a steam thermal power plant. Now tell me one by one. Breton cycle. What is the power plant that works on Breton cycle? Breton cycle is basically it gas turbine. It runs a gas turbine. So basically the phase does not change. It remains turbine power plant. Okay. So Breton cycle runs gas turbine power plant. No phase change. Here, no phase change. Rankine cycle runs steam turbine power plant. Okay. So basically, this is your answer, but let us discuss each and every point. Now, here water changes to steam. That is why it is called a steam power plant. Okay. Here water changes to steam, and that is the reason it is called a steam turbine power plant. Okay. Then Carnot cycle is basically ideal cycle, and all it is basically all cycles based on this. Otto cycle runs your SI engine or petrol engine or petrol engine. You also have diesel cycle that runs diesel engine. Okay. So what is the right answer here? It is Rankine. So B is your right answer. Okay, let's move ahead. Which parameter will remain constant in throttling process? In throttling process, which I think you simply know the answer. You must know the answer. It's very simple. But just to explain, let me tell you what is throttling process. So throttling process is when fluid passes through a very small opening, very small opening. Okay. So let us say you have this kind of pipe and a very small opening is there like this. Okay. Everything else is, filled up. Now, this side you have some fluid and it is trying to go out the other side. It is trying to go out. Now, because it is a very small opening, so only one by one it will come out. Okay. One by one, these fluid particles will come out. So here pressure is going to decrease. Pressure is going to, this process is called as expansion. But you see, very small opening means whatever fluid is coming out through the opening, there will be friction. It will be, coming in contact with the boundary. So basically, a lot of, you cannot ignore the friction. So that is why it is irreversible expansion. It is, you cannot neglect the irreversibility. It is irreversible expansion. Now, because fluid is flowing, so we can apply our steady flow energy equation. What is the steady flow equation? H1 plus V1 square by 2 plus GZ1 plus Qn by mass flow rate is equals to H2 plus V2 square by 2 plus GZ2 plus work output by mass flow rate. Now, in throttling process, you see, if you neglect kinetic and potential energy changes are neglected because there is not significant velocity, neither there is a significant change in reference. Okay. Also, it is insulated. Okay. This pipe is insulated. So Q in is equals to 0. No work output as well. So basically, if you neglect kinetic energy, then this will be neglected. Potential energy, this will be neglected. Insulated, this will be neglected, and also work output will be neglected. So eventually you will get H1 is equals to H2, and therefore it is a isoenthalpic. Your enthalpy remains constant. So this is the isoenthalpic process. Isoenthalpic process. Okay. So what is the property? Sorry. What is the property that remains constant here? Enthalpy. So throttling is a isoenthalpic process. Just mind it. Okay. I've also explained this in this slide. Okay. Let's move ahead. Again, very simple question. A steam power plant receives this amount of heat. Just 1 second. Let me draw the diagram as well so that I can explain it better. Okay. So steam power plant means what? Just now we have talked. It is your Rankine cycle. So what is Rankine cycle? Basically, this is your boiler. And in the boiler, you give Q in. Then the steam goes to turbine. Turbine give you work output. Then it goes to evaporator. Sorry, condenser. I'm really sorry. You're condensing, no? Converting steam to liquid water. So condenser. And then you will pump it back, pump this liquid, pump this water back to the boiler. So this is your pump. In pump, you will give work input. This is Q out. Now read the question. In simple steam power plant, it receives heat how much? So receive heat what? Q in 10,000, 100,000 kilojoule per minute. As heat transfer from hot combustion gases, and it is rejecting how much? This is 66,000 kilojoule per minute to the environment. If the pump receives, now work input is 1400 kilojoule per minute, the thermal efficiency of this cycle and turbine, this I need to find out. Okay, chalo, let's see. So first of all, what we can do, by we know one thing, network. What is network? Network is equals to turbine work minus pump work. So what will be turbine work? Is equals to network plus pump work. Pump work I know. If I'll find out this, I can find out turbine work. So how can I do that? So first of all, it is a cycle, right? It is a cycle. You see, it is a complete cycle. So you can apply first law of thermodynamics for a cycle. What is that? Q net is equals to work net. So Q in minus Q out is equals to work net. Okay. What is Q in? 100,000 minus 66,000 is equals to net work. So net work now you will get here is 34,000 kilojoule per minute. Okay. So you can substitute here is equals to 34,000 plus 1400, and it is equals to 35,400 kilojoule per minute. Got it? So turbine work output we have found out 35,400. 35,400 kilojoule per minute. Okay. Now they have asked in kilowatt, yani ki per second they have asked. So what can I do? Work of turbine 35,400 kilojoule per minute into 1 upon 60 seconds per minute. So this will be your 590 kilowatt. Turbine work, how much is it? 590 kilowatt. Next thing they're asking is thermal efficiency. So thermal efficiency is actually very simple. What is thermal efficiency? Thermal efficiency will be net work upon Q in. What is net work? Just now we have calculated this. 34,000. What is work? What is heat input? 100,000. So it will be 34%. 34%. So let us see what is the right answer. 34% and 590. 34% and 590. So this is basically your right answer. Got it? Chalo. It's very simple question. If you know the concept, it's really, really simple. Okay. Now, should we move ahead? Yes. Let's go. Now, what is the next question? Air at 100 kilopascal. So what is this pressure? This is temperature. 2 degrees Celsius, and this is your volume V1. It is in liters. Let me convert into meter cube. Okay. Device, piston cylinder device that is arranged to maintain constant air pressure. If constant air pressure means pressure will remain same, pressure is not changing. Now will start heating until the volume is doubled. So this is your V1, volume is doubled. 20 into 10 to the power minus 3. Work produced by the air is. So you see, what is this process? This is a constant pressure process, and you must know how to calculate. Now, if you don't know how to calculate work for a constant pressure, then it is very difficult. Okay, then you are doing something wrong, because it is a very basic concept, and work done in a constant pressure is constant pressure, final volume minus initial volume. Now, what is the pressure? It is 100 kilopascal. What is volume? 20 minus 10 into 10 to the power minus 3. Okay. So it is 100 into 10 to the power minus 3. So everything will get cancelled because it is plus 3 minus 3. And it is 1 kilojoule is your right answer. 1 kilojoule is your right answer. Okay. So it's very simple. You see, let's move ahead. Now, next question. Also, this seems to be, whenever you see heat engine, heat pump, it's very simple question. Refrigerator and all. Okay. They're very bilkul formula based question, nothing else. So a heat engine working with a thermal efficiency of 35%. So this is your efficiency of heat engine is equals to 0.35. So this is your heat engine. From T1, it is giving you Q1. It is T2 is coming out, Q2 is coming out at lower temperature T2, and work output you are getting. Now it receives 2 kilowatt of heat from a furnace. So Q1 is equals to 2 kilowatt. The waste heat rejected, I need to find out Q2. I need to find out Q2. So you see, efficiency of heat engine is equals to work output upon heat input. Now, what is work output? If you do an energy balance, here, so energy in is equals to energy out. What is coming in? Q1 is coming in. What is going out? W plus Q2. So from here, W out is equals to Q1 minus Q2. So I can write Q1 minus Q2 by Q1. So basically it is 1 minus Q2 by Q1. Simple. Okay. This is your efficiency. So let me take it here. Efficiency I got 1 minus Q2 minus Q1. Now efficiency is given as 0.35, right? 1 minus this I need to find out. Q1 is given as 2. Q1 is given as 2. Okay. So Q2 is equals to 1 minus 0.35 into 2. So this is 2 into 0.65 is equals to 1.3 kilowatt. 1.3 kilowatt. So the heat rejected is how much? 1.3 kilowatt. C is your right answer. Okay. I hope you got this. Yes. So let us move ahead. Read this question. Let me drink some water and then we'll. It's a very simple question. It's very conceptual question. No calculation is needed. I hope you can answer me what is the correct option. Quickly. I hope you will be able to answer me what is the right option. So Joule-Thomson coefficient, which is mu, is always what? Always 0 for ideal gas. Okay, and it is not 0 for real gas. So for real gases, it is basically a function of temperature and pressure. It could be negative, it could be positive, temperature and pressure. Okay, mu is a, but for ideal gas, it is always 0. It is always 0. So C is the correct option. So I don't think there can be a simpler question than this. I really don't think there can be a simple question than this. Okay, chalo, let's move ahead. Next question. Air is heated from 0 to 100 degrees Celsius in a sealed metal container. So what will happen to its density? Again, conceptual based question, concept based question. You are heating air in a sealed metal container, its density. So air means you can apply ideal gas equation. Ideal gas equation. So you see what is happening here. PV is equals to MRT. Pressure is equals to mass per unit volume RT, and it is density RT. So density will be P upon RT. Now R is constant, so the only variable are pressure and temperature, right? Now, when you are heating, so temperature will go up, right? Temperature will increase. When temperature will increase, that means molecular momentum will increase. Molecules will start moving very frequently. They will start colliding with each other, and it will also increase the pressure. So basically, pressure increase is a byproduct of temperature increase. So for a given temperature increase, let me write it here. For a given temperature increase, there is a slight increase in pressure because the volume is constant. Okay, that means if I say pressure by temperature, so temperature is increasing more, but pressure is decreasing. It is also increasing, but less. That means this value will be less than 1. Less than 1. This value will be less than 1. Okay, because it is decreasing. Okay, this value is decreasing. So because of this reason, this pressure and temperature P by T ratio is going to decrease, and therefore density is also going to decrease, but slightly decrease. You will see a slight decrease in density. Slight decrease in density. Okay, so I hope it is clear. So decreases slightly is the correct answer. Okay, now next question. If a certain mass of moist air in an airtight vessel, okay, very important to know, it is an airtight vessel. It is an airtight vessel. Is heated to a higher temperature. So temperature is increasing. Okay, then so you see, first of all, the point to note here is it is only heating. Okay. Second is no humidification or dehumidification because it's an airtight vessel. Okay, you are not adding anything. Dehumidification. Dehumidification. Okay, so I hope you are all aware of this diagram which we talk. So here it is absolute. So you see here, first of all, they're talking about specific humidity or relative humidity. So let us see what is the effect on specific or relative humidity. Now, here it is, and here it is dry bulb temperature. Now you are all aware, if you are doing heating, then you are going to this direction. Okay, so this is your point 1, this is your point 2. Now what is specific humidity? Specific humidity is equals to mass of vapor per unit mass of dry air. Okay, so you see, because it is an airtight vessel, mass of vapor is not going to change, also mass of dry air is not going to change. Therefore, this will remain same. Okay. Now, what will happen with relative humidity? Now, relative humidity is mass of vapor per unit mass of vapor in saturated condition. So, what is this? This is your vapor absorption capacity. Now, it's very important now what I am saying, that as the temperature increases, what will happen? Air will expand, right? And at higher temperature, air has higher vapor absorption capacity. So its vapor or water absorption capacity increases. And it simply means that mass of vapor that it can absorb in saturation condition, it is going to increase. So your this is constant, of course, but this is increasing, and therefore relative humidity is going to decrease. It is going to decrease. Here nothing is changing. This is also constant. This is also constant. But here this is constant, but this is increasing. That means relative humidity is going to decrease. So what is the right answer? Specific humidity of air increases? Nothing. These are wrongs because specific humidity will remain same. What about relative humidity? It is going to decrease. So D is your correct answer. Got it? I hope it is clear, crystal clear. Okay, let's move ahead. Next question. A system is undergoing a cycle that consists of three processes. During the first process, let me take it on the other page. Okay, so we have a cycle, right? We have a cycle. Three processes are there. Any random three processes are given. So let us say first process, second process, and this is your third process. So we are going from 1 to 2, we are going from 2 to 3, and then 3 to 1. Now during the first process, work is 5 kilojoule. That means work out, because it is positive, it means it is work output. So work 1 to 2 is 5 kilojoule, and heat is positive. That means it is in Q1 to 2 is equals to 23 kilojoule. In the second process, no work done takes place. So work 2 to 3 is 0, and the heat interaction is minus 50. That means minus means it is going out. 2 to 3 is equals to minus 50. Now, if I have taken it outside, so I don't have to write minus here because I have shown it going outside, right? I have shown it going outside, so 50 kilojoule. The third process is adiabatic. Adiabatic means what? Q 3 to 1 is equals to 0. Only work. And let me assume that work output is happening. This I need to find out. Now you see this is a cycle, right? So first law of thermodynamics for a cycle. What is first law of thermodynamics for a cycle? It is Q net is equal. Just now in this session only we have talked about this. Okay. So Q1 to 2 plus Q2 to 3 plus Q3 to 1 W122 plus W223 plus W321. Now you see this is 0. Okay. And this is also 0 because you see this is given adiabatic and this is given 0. Now this is 23 and this is you see going out. So minus 50 is equals to W12 is 5 plus 31. Okay. So this will be 23 minus 50 and so this is minus 32 kilojoule. That means our assumption was wrong. It is consuming. Our assumption was wrong. It is basically work input is there. Work is going in and how much? 32 kilojoules. The answer is minus 32 kilojoule. That means work is absorbed by the system. So what is the answer? Minus 32 kilojoule. This is your right answer. Okay. So I think this is the end of our this session. Okay. So we have solved, I think, around 15 questions today. And I hope you are getting good practice of your ISRO and ICRB questions because this will be really, really helpful. All the questions you see, they do not only, consist of just numerical, just putting the formula and just putting the values in the formula. No, there are so many good conceptual questions that you will only build when you understand the concept. Otherwise, you will not understand them. Okay, there is no other way than to go back and revise your concepts if you want to attempt the ISRO question. Okay, chalo. So I hope we are done for today. I will see you on Wednesday at the same time again. Okay, and we will practice questions of 2017. Okay, so I hope this is goodbye here. I will see you on Wednesday. Thank you very much.